Welcome everyone. In this video we are going to continue talking about transformations, and this time we are going to figure out the distribution of a particular random variable u that is a function of some other variables y1, y2 to yn, where we're kind of thinking about these y's as having a known distribution. So we know the distribution of each of the y's. We do not know the distribution of u. That's what we're interested in finding. And for our particular case, we're only really going to do this with either a univariate y, so just some function of one y, or a bivariate case. Okay, so sometimes this method of distribution functions is also called the method of CDFs. So distribution functions refers to cumulative distribution functions, something we talked about earlier in the semester, that are now going to come back. And so what we are going to do here is we're thinking about finding the CDF of u just by the definition of a CDF. And so we're thinking about, again, it's been a little while since we've seen CDFs, but we're thinking about how much probability has accumulated up to some number. Once we figure out the CDF of u, we're just going to differentiate that to get the density function of u. And so that's this last step here, is just a differentiation. Okay, so this will be a lengthy example. If you could believe it, in this entire video, we are only going to do one example, but that's how long these problems can be. And we're supposing that we've got a random variable y where we know its PDF, and so we know the density of y, and so we're in a setting here where essentially we've just got some little y1 there. Some little y1. We know the PDF of y, and we're interested in finding the distribution of u, which is equal to 3y minus 1. Keep in mind that if the question was just to find the expectation of u or the variance of u, that would be quite straightforward, given our operators, or given our properties for expectation and our properties for variance. But it's not. We want to find the full density function of u. And so we are going to break this down into 4 steps. And first, we're going to start by thinking about what the inverse function is. And so we're going to use that from time to time in the remaining steps. And so what I mean by that is that if u is equal to 3y minus 1, we're getting that from the problem. This is the function. Then the inverse function is what happens when we try to solve for y. And so if we try to solve for y, we end up with u plus 1 equals 3y, and then that implies that y is equal to 1/3 times u plus 1. And so this is the inverse function. You likely encountered inverse functions in calculus, but remember, all this is that if I threw this quantity in for y, I would end up with a u. And so if I plug this in for y, I would do 3 times 1/3, that cancels, u plus 1 minus 1, that would just leave me with u. That's the definition of an inverse function. Practically speaking, we're just solving for it by rearranging y and u in the equation. Okay, step 2 is to then find the support of u. And the first thing we're going to take note of is that the support of y is between 0 and 1. And so what this means is that probability only accumulates when y is between 0 and 1. And so we have the support of y. We want the support of u. So again, for y, support is given in the problem. For u, though, what we're going to end up doing is we're just going to make use of that inverse function that we just calculated. So for u, if the support of y is between 0 and 1, then the support in terms of u must be 1/3 times the quantity u plus 1 must be between 0 and 1. So again, just putting that there. From here, we are just solving this so that u by itself is in the middle. So if I multiply everything by 3, I end up with that. And then if I subtract 1 everywhere, I end up with u support as being between -1 and 2. And what this means, again, is that u accumulates probability between -1 and 2. Okay, so we're a little bit of the way there at least. At least we know the support of u. Now, what we are going to do next is we're going to build up the CDF, so the cumulative distribution function of u. And I'm going to put in the easy parts first. So remember, this was defined as the probability that u is less than or equal to some number little u. So little u can be any number from -infinity all the way up to infinity. And the parts that I'm going to fill in right away are, I'm going to say, okay, well, if u is less than -1, no probability has accumulated because the support of u is between -1 and 2. So I'm going to put in a 0 there. If u is bigger than 2, then that means all of the probability has already accumulated. Again, because the support of u is between -1 and 2, by the time I reach 2, all of the probability is there, and so I know that that part of the CDF is 1. That leaves me one part left to solve for, and that's the part that u actually has support on. And so see if you can stick with me through some of this logic. So I'm going to start with the definition of the CDF of u. Then I know that u was defined as 3y minus 1. And so I'm thinking ahead. I really want this quantity to be in terms of capital Y, not in terms of capital U, because I know the distribution of capital Y. So what I'm going to do is I'm going to plug in the definition of the random variable u, which is just from the problem. Little u is still just some number, so that just stays the same. And then what I really want to do is I want to make use of the fact that I know the density function of y. And so I want y to be all on its own on the left-hand side of this inequality. And so all I'm going to do is rearrange algebraically these terms to get that y is less than or equal to u plus 1 over 3. That's just adding 1 to both sides, dividing by 3 on both sides. And now we're in much better shape. U, again, is just a number, so lowercase u on the right-hand side here is just some number. And so I can actually then figure out the CDF by integrating from 0 up to 1/3 u plus 1. And because I have a capital Y by itself on the left-hand side of this equation, I know that I could just use the density function of y directly here. So that's 2y dy. Finally, we have a integral that I would rather do by hand instead of going to ChatGPT. So integrating 2y, we get 2 times y squared over 2, which is just y squared. Evaluate it at our bounds of 0 and 1/3 u plus 1. That gives me the quantity 1/3 u plus 1 squared minus 0 squared. I miswrote my squared symbol before, so that should go outside of the brackets. And that is just equal to 1/9 u plus 1 squared. So that's the missing piece. Again, what I've done here is I've started over here with the definition of a CDF. I've plugged in from the problem how y and u are related. I've then solved that so that y is just on the left side because I want to use the density of y, and this is the easiest way to do that. And then from there, it's just algebra. So the stuff on the left is really the more conceptual stuff. The stuff on the right is just algebra to get the missing piece of that cumulative distribution function. Okay, but we are not done. The last step is to differentiate that to get the density function of u. Though I think step 3 is the hardest. I think once you get through that, step 4 is a lot more straightforward. Differentiating 0, that's just a constant, so I get 0. Differentiating 1 is also a constant, so I get 0. And so the work then is differentiating the middle piece. And that is going to be 2/9 times u plus 1. You could do that by hand. You could do it with ChatGPT, whatever floats your boat. And so then our full distribution function with the support, which I've omitted up here because I ran out of space, is that the density function is 2/9. So the full support of the density function, in case I misspoke a few seconds ago, is 2/9 u plus 1, and that occurs when u is between -1 and 2, and 0 otherwise. Something you can do, if you would like, is you can check to make sure that we didn't make some algebra mistake. And if we've done this correctly, then the integral between -1 and 2 of 2/9 u plus 1 du, that should equal 1. If that does not equal 1, we do not have a proper probability density function, so we made a mistake somewhere. And so again, I will do this by hand. This is more on the border of what I would want to do by hand, but I don't want to hop over to ChatGPT. So that's 8/9 minus 2/9 minus a half. Cancel. 8/9 plus 1/9 is 9/9, which is 1. So we do at least, it doesn't say for sure that we've done it right, but at least we ended up with a proper probability density function.